Good morning, students. My name is Abhishek Sachdeva. I am from Lalpur Khalsa College of Engineering, Jalandhar, Department from Civil Engineering. So, students, this is the lecture for Civil fourth semester class, and the subject is concrete technology, and the topic it is the design of M40 grade of concrete as per the design considerations which are given in IS 10262 2009. So students, previously we were discussing the design steps for the same problem, which was the design of M40 grade of concrete, and this problem that has been well explained step by step in your IS 10262 code also. So we are taking into the consideration various factors which are given into the design of the concrete as per this IS code. Students, I am particularly focusing on certain parameters. I am particularly focusing on that certain paragraphs which are required in the mixed design procedure. So step by step we have discussed in the last lecture also the mixed design of M40 grade of concrete, and I have highlighted the various paragraphs. I have focused on various clauses of IS 10262 2009 which are basically interlinked or correlated with the design parameters and the design procedure. So you can see this was the process, and this was the question, the problem, the data which is given to us. Before starting the M40 grade of the concrete, you have to go through this A1 and A2, right? And based upon that, we have started with the question, and which was the first step, the calculation of the target mean strength that I have discussed, then the selection of the water cement ratio, and then the finally the selection of the water content. And the various steps they were discussed in concurrence with the clauses which are given in IS 10262 2009, and I have focused on the clauses also in the last lecture. Now, as per the continuation, this selection of the water content, we have derived 140 liters, that means 140 kgs per cubic meter of the water content. We have derived water cement ratio was fixed as per the experience and as per the recommendations which are given in IS 10262. It is 0.40 we have taken, and the target mean strength, that is 48.25 Newton per mm square as per the standard deviations which was taken from the IS 10262. So students, further continuing this question, uh, A6 calculation of cement content. The next step is the calculation of the cement content. And you can see how this cement content has been calculated. Earlier also in the previous problem, in the previous design, I have explained you this. Water cement ratio which we have adopted is 0.40, and water oblique cement, it is equal to 0.40. We need to get the cement content, for which it will be the water content, that is 140 liters or 140 kg per cubic meter which we are taking, divided by 0.40, which is your water cement ratio. We will get the cement content which will be equal to 350 kg per meter cube. So students, from table 5 of IS 456, minimum content, minimum cement content for severe conditions, as it is mentioned in the statement, the conditions are severe for our M40 grade of concrete design. The minimum cement content value, it will be 320 kg per meter cube. So you can see this table 5 exposure condition, it is severe, reinforced cement concrete mentioned in the statement, the question, and the minimum cement content kg per meter cube, it is For severe it is 320. So minimum cement content is 320. As per our calculation, as per our calculation, the cement content we have derived 350 kg per meter cube. So for severe condition, the content is 320, hence 350 it is greater than 320, hence the content which we have derived it is okay. So we will go ahead with the cement content equal to 350 kg per meter cube. So this is the calculation of the cement content, right? Based upon the water cement ratio and based upon the uh, quantity of the water, we have derived the quantity of the cement, which is 320 kg, sorry, 350 kg per meter cube, and we have verified this value, we have verified this figure from the table 5 of IS 456, right? So moving ahead to the next step, it is the calculation of the proportion of volume of coarse aggregate and fine aggregate. Calculation, now we have to calculate the volume of coarse aggregate and fine aggregate content. So for this, students, from table 3, volume of coarse aggregate corresponding to 20 mm size aggregate and fine aggregate which is confining to zone 1 for water cement ratio 0.50 is 0.60. Now 20 mm aggregate size we are having, right? So from table 3, volume of coarse aggregate. So 20 mm size of aggregate, that is given. Fine aggregate confining to zone 1, that is also given, right? So as per this particular statement, you need to go through it once. As per this particular statement, volume of coarse aggregate corresponding to 20 mm size of aggregate and fine aggregate confining to zone 1 for water cement ratio 0.50 is 0.60. That means this particular values, this 0.60 value which we have noticed from table 3, 0.60 value which we have derived from this table 3, and for 20 mm size aggregate and for the fine aggregate confining to zone 1, it is basically for water cement ratio 0.50. This particular value 0.60, it is for the water cement ratio of 0.50. Now this is important, student. The value which are given in table 3, right, the value which are mentioned in the table 3, they are specifically for water cement ratio 0.50, right, and the value is 0.60. Now we will refer the table. This is the table, right? Table 3, and you can see 20 mm aggregate zone 1. The value is 0.60. So 0.60 is the value as we have taken in this question, 0.60 value. But this value is for the water cement ratio 0.50. Why I am stating this? You can see this clause 4.4, estimation of the coarse aggregate proportion from table IS, from table 3 of IS 10262. This clause is also in IS 10262, clause number 4.4. You can see approximate values for this aggregate volume are given in table 3 for water cement ratio of 0.5, which may be suitably adjusted for other water cement ratios. Now student, this is the point which I am referring in my design procedure. The table 3 values, they are for the water cement ratio 0.5, right, and they may be suitably adjusted for other water cement ratio. Now how this adjustment is to be made, right? Because in the question our water cement ratio is 0.40. Not in the question, the water cement ratio which we have derived, the water cement ratio which we have calculated, that is 0.40, and this value 0.60 is for the water cement ratio 0.50. We need to adjust this value 0.60 according to our water cement ratio of 0.40, Now students, for this, how this value it will be adjusted, you can go through this paragraph. In the present case, water cement ratio is 0.40, right? And now students, as the water cement ratio is lowered by 0.10, the proportion of volume of coarse aggregate is increased by 0.02. This we have done in this question. We have increased the volume. We have increased the proportion of volume of coarse aggregate by 0.02. That means it is not 0.60. We have increased 0.02 and we have attained the 0.62. The volume of coarse aggregate for water cement ratio 0.40, it is equal to 0.62. How we have reached this value 0.62? It is, students, it is based upon this particular line, and you need to remember this line. How, what is the rate of increment or decrement if we are not having the water cement ratio of 0.50? Then what we have to do? How we have to adjust the value? You have to adjust the value at the rate of minus oblique plus 0.01 for every plus oblique minus 0.05 change in the water cement ratio. So that means students, the water cement ratio, if it is less than 0.50, the water cement ratio, if it is less than 0.50, the volume of coarse aggregate, it will increase at the rate of 0.01 for every 0.05 change in the water cement ratio, right? As in this case, the water cement ratio is 0.40, right? So it is less than 0.50. How much value it is less? 0.10, right? So the volume of coarse aggregate, it will increase for every 0.50 change in water cement ratio. The increment, it will be 0.01, right? So for 0.10, that means 2 times, the change is 2 times, right? So it will be 0.02. For every 0.50 change, the value is 0.01. In this question, 0.50 minus 0.40, it is 0.10. So that means the increment, it will be twice. So the rate, it will be 0.02. That's why we have taken 0.02 value. So ultimately, what is the conclusion from this? If the water cement ratio is higher than this value, if it is higher than this value, then the volume of the coarse aggregate, it will be less, it will be decreased. If the water cement ratio is less than this value, that is 0.50, if the water cement ratio it is less than this value, then the volume of coarse aggregate, it will be increased. The volume of coarse aggregate, it will be increased. And what will be the changing parameter, or what will be the basis of increase or decrease? The basis will be this: at the rate of minus plus 0.10 for every 0.50 change in water cement ratio, we need to adjust the volume of the coarse aggregates, right? So therefore the corrected proportion of volume of coarse aggregate for the water cement ratio 0.40 is 0.62. Now students, for pumpable concrete, these values should be reduced by 10%. So we are considering the 90% of this value 0.62. So therefore volume of coarse aggregate will be 0.56 and the volume of fine aggregate, it will be 1. The total we are considering 1 minus 0.56, it will be 0.44. You can refer the detailed discussion in the previous example also, right? Uh, Next is mix calculation. So students, mix calculation we have discussed earlier also. How is the mix calculation done? we have calculated the various quantities, right, for cement and for water, right. Then for volume of coarse aggregate and the fine aggregate, we have derived the volume of concrete considering 1 cubic meter. Volume of cement, it will be mass of the concrete upon specific gravity of cement multiplied by 1 upon 1000. So the value is 0.11 meter cube. Volume of water, it will be the mass upon specific gravity of the water multiplied by 1 upon 1000, again 0.140 meter cube, right. Volume of chemical admixture. Chemical admixture is taken at the rate of 2% by mass of the cementitious material. So that means 2% of the mass of the cement, that is mass of the chemical admixture. It will be divided by specific gravity of the admixture multiplied by 1 upon 1000. Mass of the chemical admixture, it is 2% by mass of the cement. So 2% of 350, it will be 7. So 7 divided by 1.145 multiplied by 1 upon 1000, it will be 0.006 meter cube. Now volume of all in aggregate, right. This will be also calculated in the same manner which we have discussed earlier. So it will be 0.743 meter cube. Mass of the coarse aggregate 1.4140 kg, right. Mass of the fine aggregate 896 kgs. Students, this mixed calculations, how the calculations they have been taken place, we have discussed in the previous numerical also, and we have focused on the specific clauses of IS 10262, which has been taken into the consideration while designing M40 grade of concrete. And these are, students, very much important factors which we have discussed in this particular lecture while preparing this mixed design, right. So mixed proportion, so the for the trial one, the proportion is ready. Cement, it will be 350 kg per meter cube. Water is 140 kg per meter cube. Fine aggregate 896 kg per meter cube. Coarse aggregate 1140 kg per meter cube, and chemical admixture 2% by the mass of the cement, that will be 7 kg per meter cube, and water cement ratio which we will be taking it is 0.40. So students, thank you for today. And if you are having any doubt, any particular clause which you are not able to understand, drop me email, I'll revert you. Thank you.